In this lesson, we're going to talk about solving more advanced absolute value equations. So up to this point, we've worked with some absolute value equations that can be solved pretty easily. In pretty much all the cases, we just needed to isolate the absolute value operation, and then we could set up a compound equation with OR. Now, I know we looked at some more challenging scenarios in the last lesson where we involved some quadratic equations and some rational equations, but now we're going to go even further and look at some absolute value equations that end up either being challenging to solve or being really tedious to solve. Okay, a lot of extra work. So let's start out by talking about how to solve an absolute value equation where one absolute value operation is nested inside of another. So this is a common problem you will see. So suppose we had something like the absolute value of, you have the absolute value of 9x plus 4 minus 10, and this is equal to 21, okay? So notice that you have an outer absolute value operation, and then let me highlight this in a different color. You have an inner absolute value operation, okay? So the way you kind of attack this problem is you first consider the larger absolute value expression, okay? The one that surrounds the entire left side of the equation, the one that I highlighted in yellow. So what we're going to do is we're going to set up an OR with this guy. So we're going to drop those absolute value bars. So that would give me the absolute value of 9x plus 4, and then minus 10. And then I'm going to say this is equal to 21. Then I'm going to do my OR. So now I'm going to have the absolute value of 9x plus 4, okay, again, minus 10. Now it's going to be equal to negative 21, okay? So it's the same thought process as what we used in the previous kind of lessons, but we're going to have to do this basically twice, okay? So it's just extra work. Okay, so for this guy on the left, let me kind of move down just a little bit. We know how to solve this. This is basically what we've looked at in the past. So let me isolate the absolute value operation. So I'm going to isolate this guy now. So all I'm going to do is I'm going to add 10 to both sides of the equation. I'm going to get that the absolute value of 9x plus 4 is equal to 21 plus 10 is 31. Okay, so now all I've got to do is set what's inside of the absolute value operation equal to 31, then say OR. What's inside of the absolute value operation is equal to the negative of 31. Okay, so we get 9x plus 4 is equal to 31, or 9x plus 4 is equal to negative 31. And you can see how tedious this becomes. This is just one of those ones where it's not hard once you kind of understand the steps. It just takes a long time, a lot of scratch paper, and sometimes that can involve you making some mistakes if you're not really careful. So for this guy on the left, I'm going to subtract 4 away from each side of the equation. This is going to cancel. I'm going to have that 9x is equal to 31 minus 4 is 27. Okay, so if I divide both sides of the equation by 9, I get one solution, and that's that x is equal to 3. Okay, so that's one solution. Over here, if I subtract 4 away from each side of the equation, this cancels. I'm going to get that 9x is equal to negative 31 minus 4 is negative 35. Again, I'm going to finish this up by dividing both sides by 9. And I'm going to find that x could also be equal to negative 35 ninths, okay? So those are two solutions that we have, but we've got to go back up and deal with the other scenario. So let me just kind of copy this real fast, and I'm just going to erase all this work. Okay, and I'm just going to paste that in right here, right there, okay? So that's for this guy right here. So I'm just going to erase all of this. We don't need that anymore. And let me kind of drag this over here, and let's work on this guy now. So what I'm going to do is I'm going to add 10 to both sides of the equation to kind of get things started. I'm going to have the absolute value of 9x plus 4 is equal to negative 21 plus 10 is going to give me negative 11. Now, you'll notice that there's a problem here. We know that if we have the absolute value operation isolated on one side and we have a negative value on the other side, there's no solution. Okay? Again, if I take the absolute value of a negative number, it becomes positive. If I take the absolute value of 0, I get 0. If I take the absolute value of a positive, it stays positive. So there's nothing I can plug in for x here, multiply by 9, and then take that and add to 4, and take the absolute value and get a negative 11. Okay, it's not going to happen because, again, the absolute value operation is going to give you a non-negative result, and so this guy could never be equal to negative 11. So for this part, we would say there's no solution. Okay, there's no solution. Okay, but for the equation as a whole, we found that one part had a solution. So this is going to be the solution for the whole thing. This guy, you can just throw it away, right? That part just leads to a no solution type of answer, okay? So for this guy as a whole, the solution is going to be x could be 3 or x could be negative 35/9. All right, let's take a look at another one of these, and then we'll move on and talk about another type of problem that you'll probably encounter. So we have the absolute value of, and then inside of that, you have the absolute value of 5x minus 2, and then minus 6. This whole thing is equal to 2. So again, I'm going to start with the outside absolute value operation. And what I'm going to do is I'm going to set up two scenarios. I'm going to say that the absolute value of 5x minus 2 minus 6 is equal to 2. Then, or I'm going to also say that the absolute value of 5x minus 2 minus 6 is equal to what? It's equal to the negative of 2, okay? So just split it up into two cases, and then we're just going to start working. So over here, I know I want to isolate the absolute value operation, so I'm going to do that by adding 6 to both sides of the equation. So I'm going to get that the absolute value of 5x minus 2 is equal to 2 plus 6 is going to be 8, okay? So this splits up into two more cases, right? So we can say that 5x minus 2, this expression inside the absolute value bars, is equal to 8, or 5x minus 2 is equal to negative 8, okay? So let's solve those real quick. We'll come back up. So let me go ahead and add 2 to both sides of the equation. We're going to have that 5x is equal to 10. Let's divide both sides of the equation by 5. We're going to get that x is equal to 2. Okay, so that's one solution. Over here, let me add 2 to both sides of the equation, and I'm going to get that 5x is equal to negative 6. Divide both sides by 5, and I'm going to get that x is equal to negative 6/5. Okay, so we have two solutions. We've got x is 2 or x is negative 6/5. So let's work on the other side and see about getting some more solutions. Okay, so let me just copy these, and I'm going to erase all this work. We don't need it anymore. All right, so I'm just going to erase this part right here. And let me just drag this other one over here because we need to work with this. And I'm just going to paste these solutions in. This is what we have so far. And I'm just going to erase this and put a little comma. So x equals 2, and I'll put comma negative 6/5. Okay, let's take a look at this kind of second case. So again, we want to isolate the absolute value operation. And what we're going to do is just add 6 to both sides of the equation. And so this guy's going to cancel. We would have that the absolute value of 5x minus 2 is equal to what? Negative 2 plus 6 is positive 4. So in the other example, we saw that in our kind of second case, we had something with no solution. In this example, we don't have that, so we can keep going. So what we're going to do is, again, set this up into two more cases. So 5x minus 2, the expression inside the absolute value bars, could be equal to 4, or 5x minus 2 could be equal to negative 4. Okay, so we're just going to solve those two scenarios. So let me add 2 to both sides of the equation here. I'm going to get that 5x is equal to 6. Divide both sides by 5. We're going to get x is equal to 6/5. Okay, so that's the solution. Over here, I'm going to add 2 to both sides of the equation, and I'm going to get that 5x is equal to negative 2. We're going to divide both sides by 5. So I'll put or here. X could also be equal to negative 2/5. Okay, so we're going to have a total of 4 solutions. Let me kind of copy this, and I'll erase everything. Okay, so we have 6/5 and negative 2/5. So let me put comma 6/5 and comma negative 2/5. Okay, so those are our 4 solutions. I'm not going to check them in the interest of time, but you can plug each one in for x, and you see that you get a true statement in every case, right? So x is 2, negative 6/5, 6/5, or negative 2/5. All right, so now let's move on and look at something that's even more tedious. So we've previously seen examples where two absolute value operations were directly set equal to each other, okay? So for that scenario, it's very easy to solve. But what happens when we have an equation with two absolute value operations and then kind of an extra or a loose number, okay? So this is a very common scenario that you'll come across. So something like the absolute value of x minus 1, then plus the absolute value of 3x minus 1, and this is equal to 5, okay? So in this case, we can't directly set the two absolute value operations equal to each other, okay? So we can't use that method. So we have to kind of turn to a more advanced approach, or you could say a more tedious approach. Now, there's other ways to do this than what I'm going to show you, and I'll explain that when I get done with this method. So what we're going to do is we're going to think about the expressions that are inside of the absolute value operation. So you've got 2 of those, okay? So what we want to do is think about where these expressions are 0, Okay, so where is the expression x minus 1 equal to 0? And where is the expression 3x minus 1 equal to 0? Okay, because those represent basically our turning points. It's where the sign is going to change from positive to negative or from negative to positive. Okay, this can only happen at a value of 0. So for this one, I'm just going to solve. I'm going to add 1 to both sides of the equation. So I'm going to have that x is equal to 1. Okay, for this one, I'm going to add 1 to both sides of the equation. I'm going to get that 3x is equal to 1. I'm going to divide both sides of the equation by 3. And I'm going to say that x is equal to 1/3. So this value here of 1 is what makes this expression here equal to 0. Right? If I plugged in a 1 there, 1 minus 1 would be 0. Okay. This value of 1/3 is what makes this expression equal to 0. 3 times a third is 1. 1 minus 1 is 0. So we can see that. So we're going to use these two values to kind of split the number line up into intervals. So let me go down here real quick to a little table. So this is a good way to kind of organize the information. So one interval would be anything from negative infinity up to but not including 1/3. So this interval here. So we have negative infinity and we have 1/3. And again, neither of those is going to be included here. Then the next one, if we go back, again, the values were 1/3 and 1. So I want to think about between 1/3 and 1, what's going to happen. So what happens between 1/3 and 1? Okay, neither of those is going to be included. And then my last interval would be anything greater than 1. So I'll put a 1 next to a parenthesis and then comma infinity. Okay, so that interval there. So what we're doing here, in case you're confused, we're thinking about the value of the expression in each interval. Okay, so if it's negative, we're going to replace the expression with the opposite. And if it's positive, we just replace it with the expression itself. Okay, so if I go back up, again, this guy right here, I'm just going to copy this down here. So we have the absolute value of x minus 1, and then plus the absolute value of 3x minus 1. This is equal to 5. So when we think about this interval, anything that's less than 1/3, we know that both of these guys would be negative, okay? Because this guy right here is 0 when x is equal to 1. And this guy right here is 0 when x is 1/3. So if it's less than 1/3, both of those guys would be negative. And so you would take each expression, okay, each expression, and you would make it into its negative or its opposite, okay? So in other words, this guy would be negative of x minus 1, that quantity. This guy would be the negative of, you have 3x minus 1, that quantity, okay? So that's the expressions. We're going to be dropping the absolute value bars in each case, and we're going to be replacing those with these kind of expressions we're setting up here. Now, between these two numbers, 1/3 and 1, remember, this guy is made 0 by 1/3. So anything larger than 1/3 means that this guy is going to be positive. So I can replace this one with the just expression itself, so 3x minus 1. Then for this guy right here, again, 1 is what makes it 0. So anything that's less than 1 is going to result in this being negative. So this is negative of the quantity x minus 1. Then in this scenario here, where we're larger than 1, both of these guys are going to be positive. So I can say this is x minus 1, and this is 3x minus 1, okay? So what I'm doing here is I'm going to go through, let me kind of scroll down a little bit, and I'm going to basically replace my absolute value expression in each case with what I came up with for the interval. So for this first interval, instead of having the absolute value of x minus 1, because this guy is negative, I'm going to say it's negative of x minus 1. Then we would have plus, you'd have the negative of this guy as well. So you could put plus negative, or you just put minus, doesn't matter. So minus, you have the quantity 3x minus 1, and this is equal to 5, okay? So let's scroll down and solve this, and then we'll come back up. We just want to make sure we have enough room. So I'm going to distribute the negative to each part here. So this would be negative x plus 1. Distribute the negative, so negative 3x plus 1. This equals 5. So negative x minus 3x would give me negative 4x. 1 plus 1 is 2, so plus 2. This equals 5. And then what I'm going to do here is I'm going to subtract 2 away from each side of the equation. And we're going to find that this is going to cancel. We're going to have that negative 4x is equal to 3. We're going to divide both sides of the equation by negative 4. So divide this by negative 4 and this by negative 4. We're going to get that x is equal to negative 3/4, okay? So I want to erase everything, and I want to show you what we do here. So let me erase all this. So the solution we found in this interval is that x is equal to negative 3/4. Now, what you end up doing in this process is, if your solution lies in the interval, you accept it. If it lies outside of your interval, then you're going to reject it. Since negative 3/4 is in this interval, right, from negative infinity up to but not including 1/3, we can accept this solution. Okay, so we're going to put that as part of our solution. Okay, now we're going to work in this interval. Okay, so let me go down a little bit. So this guy right here is going to be replaced with its negative. So the negative of x minus 1. Then plus, this guy is positive, so we just say 3x minus 1. This equals 5. Okay, so let's go ahead and solve this, and then we will come back up. So distribute the negative to each part. You have negative x and then plus 1, then plus 3x, and then minus 1 equals 5. So we know that 1 minus 1, those would cancel, right? That's basically 0. So you'd have negative x plus 3x, which is 2x. And this is equal to 5, okay? So what I'm going to do from here is I'm going to divide both sides of the equation by 2, and I'm going to get that x is equal to 5 halves. Now, let me erase everything. Let me paste this in. So we have x equals 5 halves. Let me kind of do this in a different color so it doesn't get confusing. So x equals 5 halves. Does 5 halves lie in the interval, which is between 1/3 and 1, right, with neither included? No, it doesn't, because 5 halves is 2.5. So this is a solution we're going to reject, right? We're going to reject this solution. Now we're going to move on to this interval right here, which is anything larger than 1. So in this interval, both of these are positive. So what I'm going to do is I'm going to drop the absolute value bars in each case and just write what I have. So I'd have x minus 1 plus 3x minus 1, and this is equal to 5. So then I would add x plus 3x, that's 4x. Negative 1 minus 1 is negative 2. This equals 5. We would add 2 to both sides of the equation. And so we would have that 4x is equal to 7. We can divide both sides of the equation by 4 and find that x is equal to 7/4. Okay, so let me erase this once again, and we'll say x equals 7/4. Okay, so is 7/4 in the interval, again, anything larger than 1? Well, yes, it is. 7 divided by 4 in decimal form is 1.75, so that's clearly larger than 1. So your two solutions here, let me just kind of check this off. You would have that x is equal to negative 3/4 or x is equal to 7/4. So let's go back up here. I'm just going to erase this, and we'll say that x is equal to negative 3/4 and then also 7/4, right? And we rejected 5 halves. That didn't work. You can check this if you want. You can even check 5 halves and prove that to yourself that it doesn't work. If you plug in negative 3/4 here, so you have the absolute value of negative 3/4 minus 1, so minus 4/4. I'm just getting a common denominator. Then plus the absolute value of 3 times negative 3/4. Okay, then minus 1, and then this is equal to 5. Negative 3 minus 4 is negative 7. So this would be negative 7/4. And then if I took the absolute value of that, I'd have 7/4. Okay, so this would be 7/4. So that works. Okay, and then this guy right here, 3 times negative 3 is negative 9. So this is negative 9/4. Again, getting a common denominator, just write this as 4/4. Negative 9 minus 4 is negative 13. So you'd have negative 13/4. Okay, so you'd have negative 13/4. Take the absolute value of that, you get 13/4. Okay, so this is 13/4 here. And what do you get? 7 plus 13 is 20. Over the common denominator of 4, you would get 5, right? So you know this one would work itself out. So this one checks out. All right, so let's check the other one. So the absolute value of, you'd have 7/4 minus, for 1, I'm going to put 4/4. And then plus the absolute value of 3 times 7/4 minus, again, for 1, I'm going to put 4/4. So what do we have here? 7 minus 4 is 3. So over the common denominator of 4, this would be 3/4. Absolute value of 3/4 is 3/4. Okay, so that's 3/4. Then this guy here, 3 times 7 is 21. So you would have 21 here. Then 21 minus 4 is 17. So you would have 17/4. Okay, 17/4. Absolute value of 17/4 is 17/4. And you see that this works, right? 3 plus 17 is 20. 20 over 4 is 5. So you get 5 equals 5. So this works out as well. So you can also do 5 halves and prove that it doesn't work. So you'd have 5 halves minus, in this case, I'm going to write 1 is 2/2. And then plus, you'd have 3 times 5 halves and then minus 1. So we know that this would be what? This would be 3 halves. This would be 3 halves. Absolute value of 3 halves is 3 halves. So this would be 3 halves. And then this guy, 3 times 5 is 15, so you'd have 15 halves. Again, I'm going to write this as 2/2. 15 minus 2 is 13, so you'd have 13 halves. Absolute value of 13 halves is 13 halves. So in this case, you get 3 plus 13, which is 16. And so you'd have 16 over 2, which is 8. So you get 8 equals 5, which is false. Okay, that's false. So that solution where x equals 5 halves, again, you've got to reject this. This does not work. Okay, and we found that because it wasn't in the interval, we knew it wasn't going to work. Now, let's talk a little bit about the alternative method to solve this. This is one that I don't recommend because it just takes a lot more time. So what you can do is you can consider all the cases that you would be presented with this. So in other words, you can consider if this expression is positive and this expression is positive, you would just have x minus 1 plus 3x minus 1 equals 5. Okay, so that's one scenario that you would encounter. Then another scenario would be this one's negative and this one's positive. So in other words, I would put a negative out in front of this and say the negative of x minus 1 plus, and then this guy's positive, so 3x minus 1, and this equals 5. So I'd solve that equation. Right, and you keep going. So this would be positive, and this would be negative, and this would be negative, and this would be negative. So you basically have 4 equations to set up and solve, but then you get extraneous solutions. So you have to go back and check each one of those, okay? And with our method, we really don't need to check. We just need to verify that our solution lies in the interval that we've created, and then we're basically good to go, okay? So once more, the solution here is that x equals negative 3/4 or 7/4. All right, let's go ahead and take a look at another one of these. So we have the absolute value of 5x plus 3, then minus the absolute value of 2x minus 7, and this equals 21. So again, it's the same thought process. I'm thinking about where this guy is 0 and where this guy is 0. I'm using that to kind of set up intervals on my number line. So we'd have 5x plus 3. And we'd say, where is that equal to 0? So I would subtract 3 away from each side of the equation. I would get 5x is equal to negative 3. Divide both sides by 5, and I get that x is equal to negative 3/5, okay? So that's going to be one of those guys. Then for this guy right here, where is 2x minus 7 equal to 0? Well, let's add 7 to both sides of the equation. We get 2x is equal to 7. Divide both sides by 2. We get x is equal to 7 halves, okay? So basically, I'm going to have an interval that is anything less than negative 3/5. So let's write that first. So we'll put negative infinity here, up to but not including negative 3/5. Then I'm going to have an interval between negative 3/5 and 7 halves with neither included. So you have negative 3/5 and 7 halves. Again, neither one's included. And then lastly, we have an interval where we're greater than 7 halves, okay? So where we're greater than 7 halves. Okay, so let's rewrite our absolute value equation. So we have the absolute value of 5x plus 3, and then minus the absolute value of 2x minus 7. This guy is equal to 21. So again, I'm just going to look in each interval and decide where each expression is positive and negative. Again, if it's positive, I can just kind of drop the absolute value bars. If it's negative, I can drop the absolute value bars, wrap it in parentheses, and put a negative out in front, right, to change it into its opposite. So we know that if we're less than negative 3/5, both of these expressions are going to be negative, right? So 5x plus 3, I'd wrap that in parentheses, put a negative out in front. 2x minus 7, I'm going to wrap that in parentheses, put a negative out in front. If I'm between negative 3/5 and 7 halves, I know this guy right here is going to be 0 at negative 3/5. So if I'm greater than negative 3/5, that guy's positive, right? So 5x plus 3 is positive, and I can go ahead and just say it's going to be positive in this interval as well, right? Now this guy right here, this 2x minus 7, this guy is going to be 0 when x is 7 halves. So it's still going to be negative in this interval here. So we would wrap this in parentheses and put a negative out in front. And again, in this interval, it's positive because everything's positive once we get larger than 7 halves, because 7 halves makes this guy 0. So we'll say this is just 2x minus 7. Okay, so let's go through the possibilities. Let's scroll down. Let's think about the first one. So all the way to the left, I'm going to replace each one of these with their opposite. So I'm going to have the negative of 5x plus 3. And then minus, you've got to be very careful because this is a minus here. And then you're putting a negative out in front. So minus a negative is really plus a positive, right? So minus a negative, and then times the quantity 2x minus 7, I'm going to put plus. Okay, so plus 2x minus 7. Okay, and then this equals 21. All right, So I'm going to distribute this negative to each term. I'll have minus 5x and then minus 3 and then plus 2x and then minus 7. And this equals 21. Okay, let me scroll down and get some room going. We'll come back up. So this guy right here, so negative 5x plus 2x, that's going to be negative 3x. And then negative 3 minus 7 is negative 10. This equals 21. Let's add 10 to both sides of the equation. We're going to get negative 3x is equal to 31. We're going to divide both sides of the equation by negative 3. And we're going to get that x is equal to negative 31 thirds. Okay, so let's copy this. So let me just write that in here. X equals negative 31 thirds. Okay, negative 31 thirds. So is this valid? You just need to ask yourself the question, does it lie in this interval? And the answer to that is yes, right? Negative 31 thirds is more negative or to the left of negative 3/5. So you can clearly see it would be in this interval. So this guy will go ahead and check it off and say that's a valid solution. All right, let's talk about in this interval here between negative 3/5 and 7/2. So this guy's positive and this guy's negative. So let's scroll down a little bit and we'll say that we have 5x plus 3. Again, if I have a minus a negative, it's plus a positive. So you just say plus there. Again, 2x minus 7. And I really don't need the parentheses. I can just drop them. And then this equals 21. So let's just solve this real quick. I'm just going to scroll down and get a little room going. We'll come back up. So 5x plus 2x is 7x. 3 minus 7 is negative 4. This equals 21. And let's go ahead and add 4 to both sides of the equation. So we have 7x is equal to 25. Let's divide both sides of the equation by 7. We'd find that x is equal to 25 sevenths. All right, so let me kind of copy this real quick. And I'm just going to erase all this work. And we're going to go back up. So again, x is equal to 25 sevenths. So 25 sevenths. So is that in the interval, again, between negative 3/5 and 7/2? Well, negative 3/5 is basically negative 0.6 as a decimal. 7/2 is 3.5, okay? And if I think about 25 sevenths, that's a little bit larger than 3.5. It's 3.571 if you wanted to kind of go to 3 decimal places. So it is larger than 3.5. So it's outside of this interval. So we're going to end up rejecting this solution, okay? It's not going to work. So let me do that in red. I'm going to reject this. And so now we just have to check this interval here. So everything's positive. So I can just drop the absolute value bars. So we kind of go down and do that. So we would have 5x plus 3. And then basically you're subtracting away this whole thing. Okay, you've got to be careful there. So what I'm going to do is I'm going to say minus, I'm going to wrap this in parentheses, 2x minus 7. Because again, this whole thing's being subtracted away. Don't make the mistake of just putting a minus 2x and then leaving this as negative 7, because this has to be changed and so does this. Okay, you got to be very careful there. So then this equals 21. Okay, so I'm going to go ahead and say 5x minus 2x is 3x. And then 3 plus 7 is 10, so plus 10 is equals 21. Let's go ahead and subtract 10 away from each side of the equation. And we'll say that 3x is equal to 21 minus 10 is 11. Divide both sides by 3. We're going to get that x is equal to 11 thirds. Okay, so once again, let me erase everything. All right, so we found that x is equal to, again, 11 thirds. Okay, so is 11 thirds in this interval? Well, 7/2 is 3.5, so it needs to be larger than that. And if you punch up 11 divided by 3 in a calculator, you get 3.6, where the 6 repeats forever. Okay, so that is going to be larger than 3.5. So this guy is going to work out as a solution. So the two solutions are going to be x equals negative 31 thirds and then x equals 11 thirds. So let me go back up. So we'll say that x is again equal to, we have negative 31 thirds and also 11 thirds. All right, so let's wrap up our lesson and look at another common type of problem that you'll see. So let's say we ran into something like this. We have 5x squared minus 9 times the absolute value of x minus 2, and this is equal to 0. So in this particular case, we have this absolute value operation that's kind of in the middle of our equation, and we can't really isolate it. So there's kind of two different ways to solve this. One of them is just to consider the two cases and then just kind of go back and think about if the solutions that we get work, right? So you just plug them back in. The other one would be to kind of make a little substitution, and then you can consider if things are valid or not from that. So let's try it the first way, and then I'll show you the substitution method. I prefer the substitution method on this, but you can do it either way. So there's two cases here. One case would be that this value here is going to be positive. So in that case, we just remove the absolute value bars. So you would have 5x squared minus 9x minus 2 equals 0. And then the other case, kind of the case over here, would be, let's say this expression was negative. So then I'd remove the absolute value bars and I would make x negative x, right? So we would have 5x squared minus 9. It's being multiplied by this, and I'm multiplying it by the negative of x. And then minus 2, and this equals 0. Of course, we could simplify this because negative times negative is positive. So I can now write this as plus 9x. Okay, so plus 9x. And let me kind of tighten this down a little bit. Just move that over there. Okay, so let's start over here on the left. So this is something we can factor over here on the left. So let me kind of set this up, and we'll factor this guy real quick. So I know that this is going to be 5x, and this is going to be x because this is a prime number here. So I need to make sure the outer and the inner work itself out. So I'm looking for what? I'm looking for a middle term of negative 9x, and I'm looking for a final term of negative 2. So when we think about negative 2, we know something's got to be positive and something's got to be negative, okay? So we also know that the factors there could be, 1 and negative 2, or it could be negative 1 and positive 2, okay? So let's say I put my negative 2 here and my positive 1 here. Would that work? So in this case, 5x times negative 2 would give me negative 10x. And then 1 times x would be plus x. So this does work itself out. Negative 10x plus x would be negative 9x. And then if you think about 1 times negative 2, of course, that's negative 2. So this is our correct factorization here. And now we can just solve this pretty easily. We're going to take each factor and set it equal to 0. So 5x plus 1 equals 0. And then we're also going to have that x minus 2 is equal to 0. Let me kind of scroll down real quick. Get a little room going. And so to solve this one, I'm going to subtract 1 away from each side of the equation. I'll have 5x is equal to negative 1. Divide both sides by 5. And I get x is equal to negative 1/5. Okay? Then over here, let me add 2 to both sides of the equation. And I get that x is equal to 2. Okay? Now these are just proposed solutions. We actually need to check them in this scenario. So let me erase all this. And I'm just going to copy these. So I'm just going to put this over here. We have x is equal to 2. And then comma negative 1/5. We'll check them in a minute. We're going to find that some of these won't work. So let's move this over here, and let's work on this now. We'll get the solutions for this, and then we'll check everything at once, okay? So for this guy, we can also solve this with factoring. So let's go ahead and set this up. So we can, again, do 5x and x. Again, I'm looking for the outer and the inner, such that I get a positive 9x as my middle term and a negative 2 as my final term. So instead of doing a negative 2 here, I'm going to do a positive 2. And instead of doing a positive 1, I'm going to do a negative 1, right? Because my outer would be 10x, and my inner would be minus x. So 10x minus x would give me my positive 9x, and then negative 1 times 2 would be negative 2. Okay, so we're good to go there. All right, so now I'm just going to set each of these equal to 0. So 5x minus 1, if that equals 0, we're going to find that we add 1 to each side of the equation. We'll get that 5x is equal to 1. Divide both sides by 5. And we're going to get that x is equal to 1/5. Okay, so let me just write that in here. So we have 1/5. And I'll just erase this. We don't need this information anymore. And then we also have x plus 2. We're going to set that equal to 0. Of course, that gives me a solution. If I subtract 2 away from each side, that x is equal to negative 2. Okay, let's put negative 2 in there. All right, so let's erase everything. And now we just want to check our solutions and see what works and what doesn't. Okay, so we have 5 times... For x, I'm going to start by plugging in a 2. So you'd have 2, that guy squared, then minus 9 times the absolute value of 2, right? Plugging that in for x. Then minus 2, and this equals 0. Okay, so 2 squared is 4. So you'd have 5 times 4, then minus 9 times the absolute value of 2. The absolute value of 2 is 2, so 9 times 2. Then minus 2, and this equals 0. 5 times 4 is 20. Then minus 9 times 2 is 18. Then minus 2, and this should equal 0. And this is going to work out, right? 20 minus 18 is 2. 2 minus 2 is 0. So you get 0 equals 0. So this guy checks itself out. Now let's work on negative 1/5 now. So let's erase this, and we'll do negative 1/5. So I'm going to erase that and that. I'm going to put negative 1/5 in there. All right, so essentially if I square negative 1/5, I would get 1/25. So I have 5 times that guy, then minus 9 times. The absolute value of negative 1/5 is 1/5, and then minus 2, and this should equal 0. So this guy is going to cancel with this guy and give me a 5. So you've got 1/5 minus 9/5. You can go ahead and do that real quick because they have a common denominator. 1 minus 9 is negative 8, so that would be negative 8/5. So you have negative 8/5. And then we're subtracting away 2, so I can go ahead and write that with the common denominator and say minus 10 over 5, right? 10 over 5 is 2. And this should equal 0, and obviously it doesn't, right? If we do this, it would be negative 18/5. Okay, negative 18/5. And that is not equal to 0. This is false. So we're going to reject that solution. Now, I don't actually need to check 1/5 because I'm going to get the same kind of result here. If I squared 1/5 is the same as squaring negative 1/5. In either case, I'm going to get 1/25. If I take the absolute value of 1/5, it's the same as taking the absolute value of negative 1/5. So this would be the same, and this would be the same. So you can go ahead and reject that as well. Okay, so get rid of that. Then the other guy that you're going to have was negative 2. So let's go ahead and check that. But again, you know that's going to work because 2 worked, and you're going to end up with the same scenario, right? Because negative 2 squared or 2 squared each give you 4. So in each case, you're going to have 20 there because 5 times 4 is 20. Then you're subtracting away 9 times 2 in each case, because whether I put a negative 2 in there or a positive 2, when I take the absolute value of that, I get 2, right? Either way. So 9 times 2 is 18. And then you've got minus 2, and this equals 0. Again, 20 minus 18 is 2. 2 minus 2 is 0. So you get 0 equals 0. So this does work out as well. So this gave us 2 solutions, x equals 2 or x equals negative 2. So I can just erase those. Just kind of tighten this down and say negative 2 there. And now let's think about doing this in an alternative way. So for this method, we're going to focus on using a substitution technique. We used substitution to solve things earlier in the course, so it shouldn't be something new for you. Basically, what we're thinking about here is the fact that x squared is always non-negative, and so is the absolute value of x squared, right? So if I think about x squared and I think about the absolute value of x being squared, this would produce the same thing no matter what I plug in for x, right? If I plugged in, let's say, negative 3. Let's say I plugged in a negative 3 in each case. Well, here, negative 3 squared is 9. And here, negative 3, if I take the absolute value first, I get 3. When I square that, I get 9 as well, right? So what I can do here is I can just rewrite this. And I can say that we're going to have 5 times the absolute value of x, that's squared. Then minus 9 times the absolute value of x. Then minus 2, and this equals 0, okay? So now I have the absolute value of x here, and I have the absolute value of x here, okay? So what I'm going to do is just make a little substitution. So I'm going to let u be equal to the absolute value of x, okay? So now I'm going to replace the absolute value of x in each case with u. So I'm going to have that 5u squared minus 9u minus 2 is equal to 0. So this is something we can, again, solve using factoring. Let me kind of scroll down for a minute. So I'm going to put a 5u here and a u here. This equals 0. And of course, I need my outer and my inner to sum to negative 9u and my final to be negative 2. Okay, so we know we're going to do that with a negative 2 here and a positive 1 here. We saw that earlier. Okay, so we know that 5u times negative 2 would be negative 10u, and that 1 times u would be plus u. So this gives me my negative 9u. And of course, 1 times negative 2 is negative 2. Okay, so let's erase this and let's kind of solve this real fast. So I would set 5u plus 1 equal to 0. Subtract 1 away from each side of the equation. You get 5u is equal to negative 1. We're going to divide both sides by 5. And we're going to get that u is equal to negative 1/5. Okay, so let me write that over here. U is equal to negative 1/5. Okay, so let me erase this. I don't need that anymore. The other guy is really easy. You can solve that mentally. You have u minus 2 equals 0. So u minus 2 equals 0. Add 2 to both sides of the equation, and we get u is equal to 2. Okay, so let's put a 2 there. So you might be thinking, you didn't get all the same solutions that you got using the previous method. Well, we did. We just have to go back and substitute again. So let me erase all of this. We don't really need it anymore. Okay, and we're just going to scroll up. And we're going to think about what u means. So I told you that u is equal to the absolute value of x. So if u equals negative 1/5, I can say the absolute value of x, because that's u, is equal to negative 1/5, okay? Then I can also say that the absolute value of x, because again, that's u, is equal to 2. Now, here's where we save some time. We can throw this guy out right away, right? Throw this out because the absolute value of x cannot be equal to a negative value, okay? If the absolute value operation is isolated on one side, you can't have a negative on the other, okay? The absolute value operation will always give you a non-negative answer, so that doesn't work. For this one, the absolute value of x equals 2 gives me two solutions, right? It could be true that x is 2 or x is negative 2, which is exactly what we found with our other method. This one I think is just a little bit quicker because at least you're rejecting kind of the extraneous solutions right away and you're just left with the good ones.